Hey, folks, just want to take a look at number 29. This is a problem similar to one of the ones in Expert TA where we end up having two objects colliding and then there's some sliding distance after that. So let me go ahead and draw this. Okay, hey, so this one we have a physics student hurls a 315 gram ball horizontally into a 3.5 kilogram box which is at rest on a table. The baseball strikes the box with a pre-impact velocity of 54.1 meters per second. The box is filled with towels and such to absorb the blow and catch the ball. So we know it's an inelastic collision. Coefficient of friction between the box and the table is 0.714. Determine the distance the box slides across the table after the collision. So we can imagine that ball is thrown into box. In that collision, we're going to maintain momentum. The box will begin to slide, and then because of friction between the box and the tabletop, that it'll eventually slow. So I've written a few things here when we have our picture. Okay. Next is, what are we trying to find? And that's the slide distance. What information are we given? We're given the mass of the ball, and I've converted this to kilograms from 315 grams to 0.315 kilograms. Mass of the box, 3.54 kilograms. The velocity of the ball initially is 54.1 meters per second, and then we have our coefficient of friction. Hey, so what relationships are we looking at here? Hey, one I can identify is that we know our initial momentum is going to equal our final momentum before and after the collision. Okay, and that would be the collision between the ball and the box. Let's see, the other thing we're going to be looking at is how far this is sliding, so eventually you'll have to have that. And a nice relationship that'll tell us that. We could figure out time, but let's not. We do have this real nice relationship that we've used several times, that our final velocity squared is going to be equal to the initial velocity squared plus 2 times our acceleration times the distance that we're sliding. Between those, we should pretty much get it. And maybe just one other important relationship is that momentum is equal to mass times velocity. Let's go ahead and see if we can use these things to solve this problem. Hey, first I want to take a look at what the initial momentum is, and that's really just going to be the mass of the ball, 0.315 kilograms, times the velocity of the ball, 54.1 meters per second. I can see that my initial velocity here is 17.0. I'll put all these decimal places here. 17.041 kilogram meters per second. There is no momentum from the box because it's at rest. Okay, our final momentum, we know that box and ball stick together, so that's going to be equal to the mass of the ball plus the mass of the box times that final velocity. Okay. Remember, this is going to be the final velocity that will become the initial velocity when we start sliding. We know that our initial velocity is equal to our final velocity. So let's go put some numbers in here. I have 17.041 kilogram meters per second. It's going to be equal to mass of the ball, 0.315 kilograms plus the mass of the box. I'm not running out of space. 3.54 kilograms times that velocity that we're looking at. Hey, we've solved for everything but our final velocity. A little bit of algebra to tell us this. Let me see if it's still writing. Yep. That our final velocity is going to be equal to 17.041 kilogram meters per second divided by that mass, which is that mass, 3.855 kilograms. If I do my math right, it looks like I get about 4.42 meters per second. Hey, let's see how far this thing ends up sliding. Hey, when it slides to a stop, I know my final velocity is going to be equal to 0. My initial velocity is now going to become the velocity we just figured out, 4.42 meters per second. Hey, let's use our handy kinematic equation here, and we're looking for x. Hey, I guess the one other thing we are going to need is what that acceleration is. Let's see if we can figure that out. Hey, as this thing is sliding, I have a force of gravity down. I have a normal force up. And I've got a frictional force opposing that motion. My frictional force is going to be equal to my normal force times mu. My normal force in this case, we can see that it balances with the gravitational force, is mass times gravity times mu is equal to our frictional force, which really is just equal to mass times acceleration. Hey, this will work out well. Let's go ahead and cancel masses. We know that our acceleration in this case is really just gravity times mu. That comes in handy. Alright, hey, so let's go ahead and we'll put our numbers in, see if we can solve this. Hey, so I have a final velocity squared, that's going to be equal to 0, is going to be equal to my initial velocity squared, we're going to have that here, plus 2 times my acceleration is going to be gravity, 10 meters per second squared, times mu 0.714. Hey, I can see that my acceleration is going to be, it's going to oppose motion, so I'm going to say it's minus 7.14 meters per second squared times that distance I'm going to be traveling, x, and that's actually what we're looking for. Let's go ahead and plug this in, isolate for x. Okay, so let's go ahead and let's say x is going to be equal to my velocity squared, 4.42 meters per second, and that entire value squared divided by 2 times 7.14 meters per second squared. Do a little bit of math there, and I find out I get 1.38 meters. Hey, so you may wonder, hey, how come I didn't have this minus sign? When I brought it over the other side, it became positive, and then I, let's see, then I ended up dividing, that's right. Oh, I'm sorry. When I brought velocity squared to the other side, it became negative. Then I divided each side by negative values, so I just ended up canceling them. Sorry about that. Okay, hey, but we end up getting an answer. Does it make sense? We got meters squared over second squared on the top. We have meters per second squared on the bottom. Our second squareds will cancel. We have a meter squared divided by a meter. We're left with meters. This should help you with, what was it, 6A on Expert TA. Hey, good luck with that.